Hardware to Save a Planet explores the technical innovations that are giving us hope in the fight against climate change. Each episode focuses on a specific climate challenge and explores an emerging physical technology solution with the person bringing it into reality. I'm your host, Dylan Garrett. Hardware to Save a Planet is brought to you by Synapse. Make sure to click subscribe so you don't miss any future episodes. Thanks for listening. Hello and welcome to Hardware to Save a Planet. I'm here with Michael Rigney, the CEO and co-founder of Cala Systems. Michael and his team have developed an intelligent heat pump water heater for homes. Apparently, residential water heating accounts for 3% of all U.S. greenhouse gas emissions and 19% of home energy use, which also means it's a big chunk of a home's energy bill. Cala's water heater is reducing both costs and emissions with a combination of hardware innovation and software intelligence. They're taking reservations now, and their first product is due to ship in 2025. I'm really excited to hear more about it from Michael. To introduce him quickly, he has over 20 years of experience at startups, primarily in leadership positions in the energy sector. A lot of his work has been focused on driving emissions reductions by supporting the modernization of our electric grid. He also has some hardware cred with a mechanical engineering degree from Dartmouth, so hopefully we can geek out a little bit. Michael, it's really an honor to have you on the show. Thanks a lot.
Thanks, Dylan. It's a real pleasure to be here.
So we have something in common, which is that we both did our undergrad in mechanical engineering. I graduated around 20 years ago, 2006. And to be honest, I found it hard at that time to find a job I was excited about at the intersection of hard tech and climate. It wasn't until kind of this current climate tech wave that I was able to really pivot my career in that direction. It looks like you were a lot more successful doing that from scrolling through your LinkedIn. So it looks like kind of really early in your career, you made that move in that direction. I was just curious to start, what was that path like for you going from a mechanical engineering degree into the energy sector?
Yeah, thanks for the question. I always wanted to work in energy and climate. It's part of why I studied mechanical engineering as an undergrad. And I think that's because I became aware of sort of climate change. I remember becoming aware of climate change as a teenager, and then reading more about it and just sort of focusing in that direction. But when I came out of undergrad, first was really, I remember actually looking for jobs in the space, couldn't really find anything. And frankly, at that age, didn't have the wherewithal to drive the kind of independent job search that was really needed to do that, in 96, 97, which is when I was getting out of college. And then I felt a draw towards potentially being in business. And just because of where I was interested, like I always enjoyed having a combination of engineering classes and then something else. Dartmouth has that liberal arts as well. So really enjoyed sort of that balance between the two. And then ultimately, so I ended up going in a different direction for a couple of years right out of college. But when I went back to graduate school to get an MBA, I did that specifically to move into energy and climate. And at that point, which was finishing that up in 2004, I was able to make the transition into the space that I wanted to work in. That joining a company called EnerNOC, which did really, really well, a big formative part of my career, over the 2000s as the current commercial industrial, space came into existence as we know it today.
And that must have been just a really different time in the energy sector than today, right? Like I was looking back at sort of charts of like solar and wind production over time. And back then it was just sort of barely a blip on the radar.
That's right. It was really different. It was nascent, so for me, when I was looking for that first job, it was 2003 to 2004. Wind was scaling at that point. It was clear that wind was going to be a grid scale technology and really successful. And in fact, I had my summer internship at GE Wind as an MBA in their MBA program. And then ultimately, but I wanted to go early stage when I came out of business school. And one of the challenges at that point was a lot of the startups were really technical. And as a business person, I was like, okay, I really may end up in a place where you're waiting for a couple of years to see if the technology is going to work. And because of that, you're not really in the phase of your career where you're actually able to drive business. And so one of the things, there were a couple, but one of the things that was exciting for me about EnerNOC was it was operational. Demand response solves an incredibly important problem, but it does it with business services and information technology. So it didn't have like fundamental technology risk, which at that point was really exciting. And the whole thing, the whole space was really exciting as well.
I'm actually really curious to hear the origin story of Cala Systems because it you've kind of spent so much of your career looking at our energy sector at what looks to be, to me, this kind of high level systems view. And then Cala is solving a very specific, I mean, a big challenge, but something very specific kind of in the home. I'm curious, like, how that happened. What were you doing in the energy sector that sort of motivated you to start Cala?
Yeah, before college, there were three big chunks to my career, starting in 2004. The first was demand response. I mentioned that, and then I was at a hardware company for power distribution, actually, so power electronics for power distribution. And then I was at a software company called Energy Savvy, that served utilities with enterprise software. And that company was acquired as part of a roll up. They created a company called Uplight, much bigger company that those who work in that space will know. And that was a really natural point in 2019 for me to transition out. And so I did, and I took some time to really think about what I wanted to do next. And there was a period of reflection, Dylan, in which I looked back at my career and I looked back at my education, and I said, I really want to do hardware again. Like I've done a number of different things across my career. Only one of them has been hardware. Hardware is really important. Yeah, it's hard, it's difficult, but hey, I want to go in that direction. And so decided to focus my efforts on what I wanted to do next on hardware. And I knew that I was going to seek to start something. I'd been at the very earliest stages of startups before and wanted to go on that journey again. And I found myself in a place where at the end of, it was like 2019, right at the end of the year, I just looked through intellectual property briefs, like a couple thousand of them, really, really quickly, like the synopses, like the paragraph level. And I just gathered the ones that met a couple of criteria that I had, and two of them related to water heating. And for me, when I went and looked at the water heating space, it was one of those moments of real pattern recognition, where the proverbial light bulb goes off, and after about half an hour to an hour, I stood up and I walked around the block and I said to myself, hey, I think this is it. I think this may be a really interesting space that's worth a decade or more of my life. And really that was because I saw three things from my personal perspective, which was heat pump water heaters would rise from being a really, really small percentage of the water heating market, less than 1% at that time, well under, to really significant share. Now, that's number one. Number two, I saw an opportunity to make a better product. And that was pretty clear to me that was there, particularly given my background, which includes a lot of work in the electric grid. And then the third was I didn't see other people doing it, didn't see other startups working on it. And that was really exciting too. So those three things really jumped out at me. And then I spent the next couple of months both learning about the idea and trying to disprove it, because I think the first thing that's really important to do is to try to prove to yourself that it's actually not worth going and doing. And then only if you can't do it, then do you go forward and invest yourself and focus on it for years of your life. And I couldn't do it because for all the reasons I sort of alluded to at the beginning, heat pump water heaters are, in our view, undoubtedly the appropriate technology for the decarbonization of water heating. It's just the right way to go.
What were the shortcomings of heat pump water heaters you were seeing at that time?
One of the pieces of IP that I came across that caused me to go and look at water heating in the first place actually starts to sort of point to this. It was a patent by the National Renewable Energy Lab, a team there, on predictive control of water heaters and specifically heat pump water heaters. And, so you put yourself, if listeners can, in my shoes for a second. I've got a background in mechanical engineering in the branch that's known as the thermal sciences. I spent a lot of time working in the electric grid, specifically in demand response. And boy, Dylan, if there's one thing you learn working in demand response, it's that when electricity is used has value, right? That's it. And then so add on top of that predictive control, a water heater. Well, a tank of hot water is really just thermal energy storage, right? And so it's extremely shiftable. It's inherently shiftable in time. But predictive control is the ideal and necessary technology to take full advantage of that shiftability. And so that was the basis of the initial insight that, hey, these products can be better. And we've since identified a full architecture, sensors, software, IoT, and hardware that round out that initial observation, but that initial observation is still right. What you really want to do with the water heater and with that the thermal energy storage is you want to control when, how fast, and to what temperature you heat the water, and that allows us to unlock more comfortable hot water, and that's job number one. Save more money. That's job number two. These are the two things consumers care about. And then, 6 to 10 other really interesting use cases that appeal to some, not all, but to many homeowners that we can do with this technology that have never been done before with a water heater.
Can you say more about this idea that when power is used is as or potentially more important than how much power energy you're using? It strikes me that like heat pump water heaters probably go a long way to improve over gas or resistive electric water heaters in terms of just total energy used. But why is it so important to kind of shift when that energy is used?
Yeah, well, let me start by answering that question at a grid level, and then we can come back and talk about it with respect to water heating. Basis of how the electric grid operates is that supply and demand are being met in real time. We still don't have a significant amount of energy storage, and so when demand goes up on the electric grid, then what's happening is grid operators are in real time, spinning up power plants to meet that demand. And there's a fascinating, really entertaining YouTube article that talks about how in the United Kingdom, on a commercial break for their most popular television shows, millions of Britons stand up, go to the stove and turn on these electric kettles. And so you literally have people, in the grid operator for the country is like watching the show and is like, okay, here it comes, turn on that power plant, turn on that power plant. Like that is how it actually works. And so it's all in real time. And so, so if you can, but here's the thing, the physics don't care if you satisfy that equation by turning on a power plant or by turning off a demand. And that's why demand response and distributed energy resources are so elegant. And I mean elegant from a mathematical sense, right? Where it's a simple, deeply insightful solution. We can turn stuff off. We can move it around in time. And so, one of the ways that we as a society can enable far, far higher penetration rates of intermittent renewables, wind, solar, et cetera, is by moving around the load. And the single most shiftable load is a tank of hot water, because no one cares when you put the electricity into it. They just care that it's hot when they want it. And
right. It's a lot easier than turning my thermostat down.
You don't live in your water tank, right?
Right.
Whereas of course you live in your house. And so that's sort of at a high level, and this is why demand response exploded in the 2000s and why it continues to be really important today across both the C&I space, but also the distributed energy resource space in general. And then for water heaters, again, as you pointed out at the top of the show, it's 3% of the greenhouse gas emissions, and it's roughly 3% of all the demand too in the United States. And if we step back and think about it, as a society, if you look at the energy transition, we're hurtling headlong towards building enormous amounts of energy storage. And we need to, right? That's where we're going to go. But along the way, we also need to take advantage of the opportunities that we already have. And one of the most available opportunities, sometimes the way we talk about it is like the lowest hanging fruit. One of the lowest pieces of fruit is to enable water heaters to be fully decarbonized.
Yeah, this is something I think about a lot because I've talked to people building various solutions that build energy storage kind of behind the meter, at the home, whether it's batteries or, whole house batteries, or I just talked to Sam from Impulse Labs, or what you're doing. And one thing I wonder about is, we're scaling grid scale energy storage batteries on the grid at this like crazy pace right now as well. Is there a point at which we do so well at building energy storage into the grid that we don't need this kind of behind this sort of demand shifting or load shifting at the home level?
Yeah, I'm not really worried about that. and the reason I'm not really worried about it is because big infrastructure is hard. Number one, big infrastructure is hard and it takes a long time, and we have a long way to go if you think about the final design. And then the second thing is in here, I'll speak to from the water heater side. Not necessarily the other distributed energy resources. It's just really low cost, right? So if you want to talk about it from a grid perspective, ultimately 98% of what's going to go into the product is already going to go into the product, right? And so you're talking about very, very small changes to the equipment that enables for a product for something that people are going to buy anyway. And so, whatever sort of economic grid structure we're going to get into in terms of capacity payments, energy payments, et cetera, water heaters are going to do really well, right? In fact, they already do. Like a lot of the ancillary services in PJM, here we're starting to get technical, a lot of the ancillary services, if you look back in time, that market is taken up by water heaters, right? And so, water heaters can be price takers.
Yeah, I think that's a really good point. Like I've looked at, a Tesla Powerwall for my home, and it's this totally different thing that I wouldn't need otherwise. It's a big investment, and it feels like kind of a brute force way to solve the problem if I can load shift other ways.
Agree with you, completely agree with you. And the other point that I would make is that societal cost is important, right? Energy prices are rising quickly. And so taking advantage of more straightforward opportunities, like fully utilizing the shifting capacity of existing loads, including water heaters, is really important from a societal cost perspective.
Just on the battery point, how should we look at energy storage, thermal energy storage, storing energy in hot water versus storing that same energy in a battery? If I'm going to load shift a kilowatt hour of energy, how do you compare doing that in a battery versus doing that in the form of hot water?
So two of the metrics that are used in energy storage are sort of what's the cost per kilowatt, right? And what's the round trip efficiency. And, on both of those, a water heater does really, really well. And so, in the first, we actually ran these numbers. So, the incremental hardware for storing excess energy in a water heater, you're talking about a single-digit dollars per kW. So really low cost, because essentially the critical physical component there is what's known as a mixing valve, right? Because the mixing valve mixes in cold water at the outlet. We have one integrated on every unit we produce. We think that that's essential ultimately for the decarbonization of water heating. And this is a $7 part, something like that, right? So this is a really inexpensive part. And then if you look at round trip efficiency, it's across the timescales of interest, which are hours, right, for our application, then the round trip efficiency is higher than for a lithium ion battery, right? Because you're talking about the mid to high 90s, depending on how long you're going to go and time shift it. So it's really competitive, and I would argue superior on both of those dimensions. We're going to have both, right? They're different use cases. We're going to have both, and people are going to keep buying water heaters because they're going to keep using hot water
to store energy as heat in water. If you're going to use it eventually as hot water, is a much more efficient way than to store it as in a battery and then use that energy later to heat up water.
Absolutely, and depending on where you're gathering the heat from, you get a really significant efficiency boost. So what I mean by that is, if the water heater is say located in a garage where you have temperature change over the course of the day, and you can heat the water when the air is warmer, then you get a really significant efficiency bump on top of everything else that we've talked about, right? And so, you want to pair heat pump, you want to pair a heat pump with thermal energy storage to take advantage of those type of opportunities if your application has them. Because you can't, if you're pairing a heat pump with, electrochemical storage, energy storage, then you can't do that.
Can we just talk about like the key components of a water heater? Because I want to get into the hardware a little bit, because you mentioned the mixing valve. Like, what parts of a water heater are critical to your system working the way it does?
Yeah, let's walk through it. And we've got a how it works at our website that talks about all of this. And so we're going to invite people to follow up and take a look at that too. But let's sort of step through it. So first, we have a flow meter. And this is the first time this is standard on a water heater. And so we're able to learn, how hot water is used in your home versus my home versus anyone else's home. And that's the basis of optimization, because you have to, if you think about this in almost any application, better information enables better optimization of what's going on in that process. Okay. So then, we're also bringing and let me step back and say, because it's the right place to say it, we're using that to create a prediction of, how hot water will be used over minutes, hours, 24 hours, in each home, right? And that is a continuously updated forecast. Okay. Then we're also bringing in various information streams depending on the preferences of that homeowner. And so if this home has solar on the roof, we're going to bring in the prediction for when solar energy will be produced by the system, the PV system on the roof. If they have variable pricing, of course, we'll bring that in. If they're participating in demand response, we'll bring in price signals, et cetera. If they want us to do so, if they turn this on, we will bring in weather information. And so that allows us to do things, preheat water before a storm, or a major weather event, right? And give them a resilience benefit too. So, okay, so that's data streams. All of those come in as well. And then all of that information flows into a predictive control algorithm. And, our predictive control algorithm, and this actually is what was developed by the folks at NREL. We did go out and license that technology for them. We use something called Model Predictive Control, MPC. MPC was developed several decades ago in the chemical processing industry. So think about huge facilities, right? Whether it's oil, petroleum, production of chemicals, et cetera. In the way that model predictive control works is it takes an accurate physical model of the system embodied in software, and then it runs it through scenarios over time. It scores those scenarios, chooses the best settings based upon, the scores, implements those settings for a short period of time, and then does it all again. It's an incredibly powerful, proven algorithm, and it is the gold standard for how hardware is controlled in a predictive environment. Interestingly, we haven't talked with a single controls professional while developing the product over multiple years that has said that they would prefer to go at this application with anything other than MPC. Everyone's like, yep, you want to do MPC. And there's a bunch of technical reasons for that above and beyond sort of what I just described, but people can probably see that. So for example, I'll add one. MPC inherently incorporates future data because it's running scenarios, future scenario. Everything of interest about optimizing water heating is in the future, right? That's the whole point. The whole point is to look into the future. So you want a control algorithm that inherently natively looks into the future. Well, that's MPC. So that's the algorithmic side. And then let's go to the hardware side. We're controlling a variable speed compressor and the temperature to which the water is heated. So let's talk about the compressor. Most compressors in heat pump, almost all, really almost exclusively, the compressors in heat pump water heaters today are fixed speed. The variable speed compressor has a couple of advantages, however. We can run it faster to produce more heat when there's likely to be more demand or on other use cases. And we can also slow it down, which increases efficiency by quite a bit, by 20 to 30% in the heating cycle of a heat pump water heater by running it more slowly. But if you run it more slowly, you do elongate the heating time, right? And so you want to know the likelihood that hot water is going to be used and how much is going to be used. So predictive control pairs really well with the variable speed compressor. And then I already mentioned the mixing valve. And the mixing valve really decouples, separates the temperature in the tank from the delivery temperature that goes out to the home. And that's really important for a couple of reasons. First, consistency. And people want the water to be hot when they turn the knob or the handle to the same place every time, right? Second, safety. So, humans scald pretty quickly at high temperatures, right? 130 Fahrenheit, 135 Fahrenheit, scald time, is seconds. But then in addition to that, if you want to take advantage of the thermal energy storage that's available in the tank, you need the mixing valve so that you have that separation that I just mentioned, right? And so that's the physical component that gives it to you. And so when you have that, you can overheat to a higher temperature, mix the water down at the outlet, and then you're delivering at the right temperature. And depending on the home, the climate, you get up to a 50% increase in the amount of hot water that you can deliver, from that water heater. So that's really significant. It's a big bump. And so I think what's interesting from our perspective as we've gone through the process is that everything that I just described in that stack, we view as being necessary for optimizing what you can do with a heat pump water heater, on comfort, on cost, on coordinating with other home systems, on about 8 to 10 use cases. And it's both the hardware, the sensors, and the software.
So the mixing valve will kind of adjust the ratio of hot water to cold water to get you the desired temperature.
That's correct.
And so that's kind of a dynamic, connected device that's tied in with the rest of the system. And similarly, the variable speed compressor is.
Can be dynamic or can be purely mechanical.
Oh, okay.
Yeah. So and by the way, mixing valves are common in a fair number of jurisdictions, require them to be installed as safety devices. And so, thermostatic mixing valves use a bimetallic metal to adjust according to the temperature that it automatically senses. So it doesn't have to be a motorized device.
So are all of these components things that kind of existed already, but just weren't being used together in this way?
Definitely what we're doing is executional hardware. Yeah. And so on sort of the forward edge of what's available. So for example, sourcing our compressor, which uses a medium GW, global warming potential refrigerant, it uses 513A, which is about as good as you can get in, without going to a fully natural refrigerant. We could talk about that later. Our compressor was just certified last year, in 2023 to work with that refrigerant. So yeah, so it's all about gathering best in class components into the architecture that makes sense for the future. And I think what's maybe interesting to point out at this juncture is that the way water heaters have worked for 130 years is the opposite of this design philosophy. The design philosophy for water heaters is the water cold? Okay, put some heat into it. And that's been okay for, generally what we've wanted. But there's so much opportunity and so much benefit from doing it differently. So the design philosophy for the Cala heat pump water heater is we're going to optimize water heating for comfort first. That's what people care about. For cost, that's what people care about. And then for carbon emissions, for coordination with the home, all of those factors. If you can think of it, we're going to take it into account. And really important from our perspective is that this is useful intelligence in the background. People don't want to think about this, right? People don't want to be thinking and changing settings on their water heater. You tell us up front, this is what I care about. I have solar. Okay, great. Tell us where the solar is pointed. We'll take care of it from there, right? I have variable prices. Okay, tell us what your utility is. We'll take care of it from there. Like all of this should happen in the background so that people get it on with their daily lives. And if they have 6 people over for the weekend, they can push the boost button, and we'll make sure that we maximize water heating for until everyone leaves on Sunday night.
Okay, but I don't have to say I typically shower in the morning and set a schedule for the compressor and all that.
No, and I think so we learn all that. The flow meter allows us to learn all that. And I think what's also important is that if people did go and construct those schedules, it's quite likely they're going to forget them and they're going to leave them there, right? For a really long time, which will be inefficient as the usage patterns change in the household, right? So the usage patterns should adjust themselves. It should be useful intelligence. And that's really the focus for us.
So this is kind of as you described, sort of a return to hardware for you. Are you enjoying that?
Very much so. Yeah. No, very much so. I think that I've enjoyed all the different phases of it, from the initial exploration to the R&D and now into the product development phase and heading towards, returning actually at this point towards the commercialization phase, which we will in revenue generation in 2025. Yeah, I've deeply enjoyed it.
What have been some of the biggest challenges in, technical challenges as you've gone through those phases?
Thanks for the question. I think that on the technical side, interestingly enough, I think that the technical side hasn't probably been, the hardest part of the journey. I think that in part of that is because just as we were talking about a few minutes ago, what we're doing is what I would describe as executional hardware as opposed to fundamental, R&D at the science and physics level, right? And so there's been lots of challenges, of course, because hardware is always hard no matter what you're doing. But those have been, more of the challenges that you expect, right? You expect to see as you go through the process. Is it working? Here's one. We we had in our very first field prototype, we had random interference from some other device that took like 3 weeks to debug. Right? And then like that's the stuff that and it was like didn't show up in the lab, didn't show up in any other home. And we finally figured out that when some other it was part of the heating system turned on, it was just completely randomized, certain signals in the prototype. So, this is the type of thing that you encounter while doing hardware.
And was that an intentional decision to take this executional hardware path early on? Like, were there problems you could have decided to tackle that would have been more kind of fundamental R&D and are maybe sort of often, on the product roadmap sometime in the future for Cala? Or was it just so obvious this is an executional hardware problem from the get-go?
One of the interesting things, for me, from a professional standpoint, is my career has sort of spanned across business and technical subjects. And I've been at startups for most of my career, and startups are hard. And so anything that you can do in the startup environment to minimize risk is great. And so from my perspective, executional hardware was always really attractive for those reasons. I think that the other thing that I would say is that water heating is really important, but it's also one of the simpler challenges that we need to go and solve from a societal perspective. So it's terrific that the technical challenges are less. It doesn't mean that the challenges aren't there. They definitely are. We're actually not on a trajectory is a better word. We're not on a trajectory to decarbonize water heating as quickly as we can. And I think that our view is that the architecture that we've outlined here is really necessary, because what we don't want to end up with tens of millions of heat pump water heaters in people's homes that have no awareness and no capability to respond to what's going on around them. Will that be better than what we have today? Yes. Is it where we want to get to? No, it's definitely not.
That raises a question I feel like I come across a lot, which is that, to your point, this is one of the simpler challenges in the broader scheme of kind of fighting climate change that we could tackle. It's executional hardware. Peers from the outside, like the incumbents, have all the pieces to put together to do this themselves. The people who have been manufacturing water heaters for, what did you say, 100 plus years or something?
Yeah, the first patent on a water heater was like 1889. So yeah, about 130 years.
Why is it? Like, what is it about these big companies that makes it so hard for them to go do this? Like, why do we need startups to go kind of make these changes?
Yeah, innovation is really hard. And at an organizational level, it's hard for numerous reasons. Let's just put this in the context of water heaters, right? So if you think about the software stack the whole architecture, not just the software stack, the entire product architecture that I just described, from the point of view of an incumbent, developing that would require stepping away from certain aspects of how the products are designed and built that have been in place since before anyone at that company was there, right? And so just to choose one example, sort of the design philosophy of controls that turn on when the water is cold in the tank. And so the inertia is really there, I think, for big companies. And I think that's why, and on multiple levels, on technical levels, on process levels, business structure, you name it. I think it's challenging. I think that's the role that startups play, and that's exciting.
From a business perspective, you just talked about kind of starting to enter this commercialization phase. In a lot of ways, those incumbents have, a big head start, right? They have their distribution channels, everything. How do you, as a startup, how do you go up against that? Because I imagine to have the kind of impact you want, you're going to have to scale to a pretty significant level. Mm-hmm. Right. How are you approaching that?
Focus and one step at a time. Right. And so I think, this is, maybe this is where, for me personally, Enernoc played a significant role. So we touched upon that before for listeners. There was a demand response company that was founded in 2002. It went public in 2007. And so, when a startup gets traction, you can scale really rapidly, but it's a decade-long journey. And so it's focus on what you're doing, execute one step at a time, and expect for it to be a long journey, right? And that's exactly how we think about it, is to keep just an even keel, do the work every day, but recognize that the promise is there because, ultimately there are 125 million water heaters, in America. And if we're able to realize our vision, then not just through our own sales, but through influencing the industry, because that is what happens with startups, right? Over time, we can drive the decarbonization of all 125 million of those. And I think that's both promising and a long journey and exciting to go after along the way.
What is your distribution strategy, or what will your distribution strategy be?
Yeah. So, it's right there at the website. So we're telling our story directly to consumers, which is really important for, I think, a company like ours to do. Why is it better? What does it do? How does it benefit them? All of those aspects. And so we're going and doing that. And we're working with installers. We've got a group of installers that are really excited to work with it, both here in New England, where we're based. We're based in Boston, but also in other parts of the country. And we're getting to know more. We've really appreciated the respect that the installers have given us. The vast majority of them are willing to sit down and talk with us, learn about the product. They've provided excellent feedback to us in various ways over the last couple of years. And so, we're focused on those two communities at the beginning, and then we'll add all sorts of partners over time.
As a homeowner who needs to replace my water heater, how do I look at this versus other options? It sounds like you've done a really good job of kind of keeping the cost premium to a minimum. Is there a bit of a premium? And then I look at a payback period because I'm using energy when it's cheaper and things like that. Is that the right way to think about it?
Let's start with what they have now. Because, here's the really interesting thing, or one of the interesting things about water heating. The economics of water heating in America are really driven by a couple of factors. So let's get into what they are. So the first and one of the most important ones is what fuel are you using to heat water, right? So about 47% of Americans, just under half, use natural gas. That's the cheapest fuel. About 46% use electric resistance. And the balance, about 6 or 7%, use oil or propane. And Dylan, for the 52% that use electric resistance, oil or propane, water heating is surprisingly expensive. And so this is why, when we launched the company, we wanted to, and we went and constructed specific examples based by fuel, right? Because fuel becomes incredibly important here. And we also think it's important to not talk in averages. It's important for people to get to know, okay, well, I have a family of 4 and I live in a northern climate where the water requires more energy to be heated over time. And then do you live in an expensive state or an inexpensive state, right? And so if you have an electric resistance water heater and it's a family of 4 and you're in a high price state, like in New England, you could be spending $1,100 a year to heat your water. So the economics are really surprising. And so that's the first thing that people should think about. And then, we're seeing, so I'll stick on electric resistance for a second. We see in our product the ability to reduce that by 75 to 80%, right? In terms of the cost of heating the water. And, that was in one of our prototype sites in North Carolina. We saw a 76% reduction in kilowatt hours per gallon of hot water delivered. And so, what fuel do I have? How much hot water am I using? How expensive are the fuels, that I'm using? And then latitude is those are the 4 real drivers. And then in terms of how people, think about it, and beyond the economics, yes, a lot of people look at payback, and looking at payback is always important. Payback versus a traditional water heater. Here I'm going to speak in broad brushes because it becomes so site specific. The payback against electric resistance, oil or propane for Cala is generally really good. Electric resistance is the best because you generally have a low install cost because you already have the right circuitry there. Okay. So that becomes almost in many situations a like-for-like replacement. And you've got the best cost savings, right? So that's 46% of the market. And then oil and propane, those are just really expensive fuels. So you're going to have a higher upfront installation cost because you have to generally run a circuit, things like that. But there's a good payback over time, generally thousands of dollars in lifetime savings there. And then natural gas, it really depends by state. You can't break it down in talk in broad brush. You have to go state by state. That's the relative cost of the prices.
Relative cost of gas and electricity in this.
Exactly.
Yeah. You've mentioned demand response, and this, I've been learning more recently about VPPs, virtual power plants, and how smart devices like this can participate in those as a way to like you said, kind of reduce demand at times of high or reduce load at times of high demand for an actual like monetary for compensation to the homeowner. Is that something that Cala owners could participate in?
Yes, but the but, Dylan, is that getting individual residential loads into these programs is generally really hard. This becomes like we could have a call just on this, right? And so this is a long journey, and it's close to my heart, having worked in the demand response industry for for 6 years. But the way I would summarize it for those at home is for listeners is that there's two fundamental ways to get into energy markets. One is through your utility, and the second is through wholesale markets, the system operator. The rules become complex. There's a lot of work to change policy here, and it will be piecemeal. It will be sort of a patchwork across the country for where we can and cannot, put our water heaters in our heat pump water heaters into markets. But we're always going to lean into that, both from a technical and making it happen perspective, an executional perspective. But over time, we also want to lean into it from a policy perspective. It's really important for manufacturers, particularly dedicated manufacturers, like we are in the water heater space, to stand up and to say publicly, hey, this is what our technology can do. The rules need to evolve. And there's a lot of work that is going to take place and needs to take place, over the next 5 to 10 years to increase that access.
Yeah, I think that's a pretty fascinating developing story. I'd love to talk more about that follow up. What's your vision for the future of Cala? What do you hope this company becomes? And what kind of impact do you think you can have?
Yeah, I think we've touched upon it already, which is to drive the decarbonization of water heating. And the way we summarize our mission is that our mission is to make water heating a zero emission comfort. And there are a couple of things about that that are really important. Obviously the zero emission part, but the second is the comfort part. The hot water is embedded in people's lives. It's when you're tired or you feel sick, like you go and take a shower, you take a bath. And so focusing on the comfort side is critically important to us from a product perspective, from how we think about the values of the company. And so, we want water heating obviously to continue playing that role in people's lives. It's essential, but we want to do it in a way, enable them to do it in a way where it contributes to the greater good as well, which is why sort of the tagline at the website is a feel good comfort. Like people should feel good about the comfort that they're deriving from their hot water.
Could that 3% go to zero water heating? Is that a realistic goal?
Yeah, and here's how it's going to happen. And so, we need deep penetration of our product and other products that have the characteristics like this. But then what's going to happen is that as the penetration rate of renewables goes up throughout the grid over the next 10 to 20 years, what we will see on a daily and weekly basis is more and more hours where the marginal power production is coming only from renewable power. For listeners at home, marginal means what is the power plant that you would add next, right? And so if we can shift and goes back to the shiftability, as we shift water heating into those hours where essentially, okay, yes, we can let run another source of intermittent renewable generation. We don't have to turn it down. That means that water heating is zero carbon, right? And so then what we will see is we will see more hours per year where certain sections of the grid are running on zero carbon, where they're running only on renewable generation. And because water heating is so shiftable, Dylan, as we move more and more water heating into those hours, we will drive it towards zero. And so I think the way I would respond to your question is to say that's the mechanism. And water heating, technically speaking, has the capability to lead the way. It should be one of the first applications in society to be fully decarbonized because it is so shiftable.
I have 3 closing questions for you, Michael, that I ask of everybody. The first is, how optimistic or pessimistic are you about the future of the planet and why?
I have a blend of 3 emotions. As someone with a background in the physical sciences, sort of I understand how the heat flows work, around the planet at a high level. And so because of that, I have a sense of awareness and sadness that, we're going to see it happen, over the course of the remainder of my, certainly lifetime and then beyond that. And so that's I wouldn't say it's pessimism, Dylan, as much as it is awareness, and arising out of that a sense of sadness. I think the second emotion that I feel is more akin to optimism, which is I see the community of people working on solutions, and I think that we have an incredible toolkit. It is growing, and the pace at which the toolkit is growing is really exciting too. Human progress and technical development is nonlinear. It's particularly nonlinear right now, and that's encouraging. I think the second thing that I find encouraging is that I think that people and natural systems are resilient. If you give it an endangered species space, it'll come back. And so I think that is encouraging for me. And then the third emotion is really a bridge between the two, and that's urgency. It's just to keep pushing.
I love that. Really well articulated. Who's another individual or company doing something to address climate change that's inspiring you?
I have a couple to call out here. The first is people in traditional businesses who make space for what's new. It's so important for startups to have business partners just from the broader economy who say, yeah, I get it. I'll try that. We see that with installers all the time. And so, those who, we sit down sometimes with installers and they're like, yeah, it's going to be heat pump water heaters. We get it. Let's hear what you got. Like, take me through it. And so that community in any field is really important. And then a little bit closer home in sort of energy and climate, I would call out two groups. It's the people working on policy and the people working in the project finance space more broadly, because those two spaces don't get as much attention, but they're just massive. So everything that goes on in those spaces is just incredibly important to what takes place. They're just huge engines.
Thanks for that. What advice do you have for someone not working in climate today who wants to do something to help?
The first is to take steps in your own life. So whether that is voting, whether that's your choices about what you buy, if you're a homeowner, go on the electrification journey, because every one of those choices has a decade plus of impact in terms of what you do. And then for people who want to work in the space, I think it's an incredibly attractive time to work in the space. It's growing by leaps and bounds. And so, get out there and have dozens of informational conversations and network. And you're likely to find something.
Michael, that was really fun. I'm really happy to have met you and really excited about what you're working on. Thank you.
Thank you, Dylan. It was a real pleasure.
Hardware to Save a Planet is brought to you by Synapse. To find out more about us and how we develop hardware solutions for the world's most ambitious companies, head to synapse.com. And then make sure to search for Hardware to Save a Planet in Apple Podcasts, Spotify, and Google Podcasts, or anywhere you like to listen. Make sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Synapse, thanks for listening.